Today I'm going to be reviewing the Kaiweets AC and DC clamp meter, model number HT208D. Later on, I'm also going to do a teardown and show you what's inside. Let's get started. This is everything that came in the original box. So it has the clamp meter, 2 probes, and temperature sensor, and also user manual, and finally a very nice case. Here's the specs of the meter. It can measure AC and DC current up to 1000 amp, DC and AC voltage, hertz, resistance, continuity, diode, capacitor, temperature, Celsius and Fahrenheit, low Z voltage, I'm going to talk about that in a little bit, and non-contact voltage measurements. It comes with 2 probes with silicon wire, and the wire is made of silicon, so it's very flexible and temperature resistant. With plastic wire, they usually break right here or right here, but silicon wire don't have that problem. On the back of the unit, we have a probe holder, so you can put it in like this, and it will fit in the case for storage, or you can put it like this for hand-free operation. The probe connector on the bottom here is not color-coded. They are the same color. You got 2 probes that have different color, but on here it's not color-coded, so you have to rely on the label on the top here. COM for the black, input for the red. There's also a flashlight on the top here, and the button is on the side, but it won't work if you just press on it. You have to turn on the unit first, and then you press and hold this button. Boom. On the back of the unit we have a place for the battery, and it takes 3 AAA batteries, so it runs on 4.5 volts. The jaw opens pretty wide, about 1.5 inches. Here's a side-by-side comparison between the Kaiweets and the Fluke 337. It's about 3/4 of an inch shorter than the Fluke. It comes with a temperature probe, and I want to see how accurate it is. So let's go ahead and test that. First up is boiling water. It should be 100 degrees at sea level, and I'm very close to sea level, so it should still be 100 degrees Celsius. Here we go. Yeah, 95 degrees Celsius, so we are about 5 degrees off. I got a bowl of ice water, and it's been in the freezer, so you can see it's in the process of freezing, frozen over on the top there. So it should be at exactly 0 degrees Celsius. Let's see what we got. I'm going to put it right in the center of the bowl. Wow, instantly negative 1.6 degrees Celsius. So that is more accurate than the boiling test. That is pretty good. Let's go over the current measurement. It can measure up to 600 amp, and if you want to go higher than that, up to 1000 amp, you can use this selection. VFD stands for variable frequency drive. This is actually a low pass filter to filter out high frequency in your voltage and current measurements. Let's go ahead and try the AC measurement first. I'm going to compare this with my Fluke meter, see how accurate it is. I'm going to use my lithium iron phosphate battery charger here to charge my battery. Each can put out about 300 watts. Let's try the AC line first. So this is my extension cord from the AC outlet. I split the wire in half, so each of the wire goes to each meter. Let's go ahead and plug it in. Wow, looks like they are in synchrony. 5.3 amps, 5.3 amp. And of course this only has 1 decimal digit here, but that is accurate enough. Let's go ahead and plug in the second charger. Wow, 9.2, 9.2, 9.3, 9.3. That is awesome. Wow, pretty cool. Let's go ahead and measure the DC current. So let's switch to DC. I'm gonna zero it. Okay. On this one, just click on function. It will turn to DC. Alright, let's try single wire first. So this is just from one charger. You see on the right we got the Kaiweets 22.46 amp, my Fluke 22.0. So that is close enough. So there you go. The performance is almost identical between the Kaiweets and a very expensive meter. This multimeter also lets you take inverse current reading. And inverse current is the initial current required to start a device. Usually that is an electric motor. To measure the inverse current, turn it on current and then press on function 3 times. I'm going to go ahead and measure the inverse current for the starter on my car. Here we go. There you go, 450 amps. That's awesome. Let's go ahead and try the NCV or non-contact voltage measurement. For this to work, you need to remove the 2 probes on the bottom. I've read the review of this model and some people complain that it's too sensitive. Merely picking it up and move it around would trigger the NCV, but not this one. You can see nothing happen when I move it around, even when I shake it really hard. Alright, let's see how well this works. I have my AC outlet here, 120 volt AC, and this ruler is to measure how far it is before it activates the NCV. Here we go. Right on the outlet. That was right on the outlet. Let's try this again. There. That's pretty good. Like, it doesn't give you like a false reading far away from the outlet. It only activates when it's on the outlet. Here we go. Next, I want to talk about the low Z voltage reading on the meter. According to the user manual, low Z allows you to measure AC voltage with a low impedance. So the meter will lower the internal resistance to prevent phantom voltage reading or ghost voltage. Let me give you an example to make it easier to understand. I have a live 120 volt AC outlet here and just a bare wire right next to it. And this wire, because it's live, it has a magnetic field through the wire, and because this bare wire is right next to it, it's influenced by the magnetic field and it produces a ghost voltage even though it's not connected to anything. This is the same effect in the transformer, except that this magnetic field here is not being amplified. So if I measure the voltage coming out of this white wire here, with regular voltage reading, it will show some voltages, even though it's not connected to anything. So I want to confirm that by using the low Z filter, and it will filter out all these ghost voltages, and it should show 0 on your meter to confirm that there's no voltages in this white wire. And because in this mode, because the meter lowers the internal resistance, the continuous measurement time cannot exceed 1 minute. So for a regular everyday use, I would just use this option instead to measure voltages. Talking about voltages, I want to test the voltage reading on this meter, see how accurate it is. So let's turn this dial to volt reading. I have a voltage reference board here. It's used to calibrate and test voltages of multimeters. It has an 8584 chip, which will put out very accurate voltages. In this case, it will put out 10 volts, 7.5 volts, 5 volts, and 2.5 volts. And this is the test result for the chip. I set the meter voltage reading to DC. On this board we got 10 volts, so we should read exactly 10 volts. Let's see what we got. 10.01. That's very accurate. I'm gonna move my jumper to 7.5. Now it should read 7.5. 7.51. 7.50. Wow, that's even more accurate. That's right on. Now we're on 5 volts. Let's see what we got. 5.01. This is close enough. It's 0.01 off, just like the first one at 10 volts. It's accurate enough, I would say. Now we are on 2.5 volts. Let's see what we got. Yeah, 2.504. That's pretty good. So there you go. The voltage reading on this meter is very accurate. I've got my AC outlet here, and this is 120 volt AC. So let's see what we got here. 121 volts AC, and on the top here it says 60 hertz exactly. So let's confirm that by going to the hertz sections. 60.02. That is pretty good. It's right on. And let's move on to the next function. This will measure ohm, continuity, diode, and capacitance. Now let's try continuity first. It doesn't react fast as I want, but it is good enough for the next 3 tests. I'm going to test for resistance, capacitance, and diode. These components are salvaged from old circuit boards, so they are old and they are used. So they are probably not even exactly what they say on the label. So this test is not for accuracy, but just to show you how this works. First is the resistance test. This one is 3.3 ohm. And we've got 3.3. Wow, that's right on. Next one is 1.1 ohm. See what we got? 1.2. 1.1. There you go. That is right on. Let's try something more substantial. This one is 39 kilo ohm. Here we go. 38.93. Let's let it focus. There we go. That is very close. Next, we got diode test. So for this, it will allow the current to flow in one direction and not the other. We're going to see some voltages if there's a current flow. So we've got 0.2 volts in this direction. So if I reverse the polarity, nothing. So it works great. Now let's try our second diode. 0.6 volt in this direction. Nothing in this direction. It's worked great. Our next test is capacitance. Let's try our first capacitor. This one is 47 microfarad. Let's see what we got. 47.2. Wow, that is right on. It's quite accurate. Next capacitor, 4.7 microfarad. Let's see what we got. 4.84. That is very close. Next is teardown time. I'm going to open this up and show you what's inside. Here is the inside of the unit. It has spring battery contact. So the bottom case of the unit, which has a battery pack, is completely detached from the top case. The first thing I want to know is how much power does it take to power the unit. So I have connected the 3-pack alkaline 4.5 volt to the unit through this meter here. It's measuring milliamp. Let's turn it on. 36 milliamps. That's how much power it takes to power the unit. Here is the close-up look of the unit. The connector for the probe is only held down by a single solder joint. Therefore, if you plug in and unplug this a lot, this might come loose, especially if you're not careful when you plug it in and out. And then if you wiggle this a lot, this might affect this solder joint and it might come loose. But for me, the function that I use the most for this meter is a DC clamp meter function. And therefore I don't use this a lot, so most of the time this is unplugged. Over here, the spring for the clamp is held together by a little piece of plastic. The clamp on this is very strong. And this piece of plastic here that's holding the clamp together is very skinny. Kaiweets should make this piece of plastic a little bit bigger. Over here we have the DMM chip, and there is no name on this chip, so I can't tell you who makes this chip. Over here we have the LCD screen driver chip. It's a TM1622. This one here is a microcontroller chip. It's an HY17P48. Up here we got the ribbon wire from the clamp meter, and it comes down and is amplified by this chip over here. And we got the speaker for the unit over here. All in all, the Kaiweets HT208D is a very well built multimeter. It passed all my tests, and the measurements on this are quite accurate. But let's face it, it's not a fluke. But for everyday use, this unit will work just fine. And you just can't beat the price. I've been using this a lot for my other review video. And this is my go-to clamp meter. And that's all I have for now, folks. Thanks for watching, and I will see you in the next video.